Hey, hello, and welcome to the show. It is time for JP's product pick of the week, which means it's me, and it's Tuesday, and you're here. I'm here. We're all together. Oop, I'm just going to punch the microphone. Thanks so much for stopping by. I was out last week, but I'm back, so thank you for coming back along with me. We've got... What have we got? We've got a couple different chats for you to check out if you're over in YouTube. Hello over in YouTube land to Dave Odessa and Dana Camp and Burton R. and Andrew Farnsworth 3130. Nice to see you. Andrew will trade the dry heat for Virginia's pollen. Woo! Yeah, I don't mind dry heat actually, and we are having pretty nice weather here in Southern California. I don't mean to brag, but the real fiery, smoky air heat is imminent, I'm sure. Over in our Discord chat. In fact, yeah, look, there it is. We've got some good people joining us here. Who's here? This is Thin Man and Paul Cutler. Scotty beam me up. Hello, Dan Caliano. Sam J. Ohio. Hello, 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 hello. Thanks for jumping in. So what I've got today, I've got a new product pick for you, and if you want to go check it out, this is the link right here. So it's product 6482. That's the QR code. You can point a device there, I suppose, and head on over. This show broadcast from inside of the product page, and what you're going to find there is the product pick is 50% off. No need for a coupon code. I'm just refreshing my browser page here to check, and yes, we have 80 in stock. Okay, we may have started with 80, we may have started with 100. But if you want to get this product, throw it in your cart before the end of the show or before they disappear, because that's how that works. So before I go further, I generally like to show a video of a new segment, but as you know, in the last few weeks, we don't have those because Lamore and PT are not doing the Ask an Engineer show right now, but I'm sure they will start that up again soon. But more importantly, Lamore is making new hardware, including this week's pick. This is a pretty new one. And I'm happy to share it with you. Let's see, the best way to do this, I just have one of them and I've got it hooked up to a demo. So let me show it right here. The product pick of the week this week is the TMP119 high precision temperature sensor. So this is a plus or minus 0.03 degrees Celsius in the 0 to 45 degree range, but it's actually pretty wide ranging. That's where it is most accurate, but it's pretty wide ranging. Goes all the way from negative 55 C up to 155 C. This is an ambient air temperature sensor, so it's not meant to be... Oh, look, my picture there is of the back side of it. Here, let me show these. There we go. Front and back are very similar on this one. So you can see we've got the little TMP119 from Texas Instruments right in the middle there, and it's on a little island or peninsula to sort of separate it from some of the thermal mass of the board there to help with improved temperature accuracy. And this is a very accurate and high precision calibrated temperature sensor, which comes with, you can even get NIST traceability on the calibration from Texas Instruments. So this is meant for serious use. In particular, cold chain assets. If you are shipping stuff and you need to be able to show that the, I don't know, salmon hasn't dipped below whatever temperature that's safe at in the truck. This is the type of sensor you want. It can be used for gas and heat meters, for thermostats, and I'll show, actually, do I have right here? I think I have listed, yeah, from their data sheet, they say electronic thermometers, wireless environmental sensors, thermostats, automotive test equipment, wearable fitness and activity monitors, cold chain asset tracking, gas meters, heat meters, and temperature transmitters. So a lot of different uses for this, and if you want to try it out, maybe you're building a small run of a product, you want to try it out easily, try it out on this little I2C board, and then you get the raw chips and use them in your final product, or maybe build something just with this. The product page right here, you can see we've got them right now for $7.48, so that's on a nice discount. And the, let's see, let me refresh this. Yeah, okay, we've got 73 in stock, so people are buying these. The board is going to work with pretty much any of your microcontroller boards, and you can use it plug and play with the little STEMMA QT/Quick connector there, JST PH connectors, 4-pin. Or you can solder in header pins. It comes with a little bit of header pin in the baggie there. You get a little section of that if you want to solder that on there and put that onto a Perma-Proto or a breadboard. But I like to use these with the Stemma QT connector. Hook it up to your microcontroller or your single board computer, and you can run CircuitPython. We have a nice library for that. You can use it with Arduino, and you can use it in Whippersnapper. So if you really want the plug-and-play, no-code, easy-to-use solution, definitely check out Whippersnapper in this. I've got a demo. It's a simple demo that I'm going to show you using CircuitPython, but any of those will work. And let's go to a learn guide for this. So if you scroll down in the main page, in fact, you'll see right here, here are the different accuracy levels at different ranges. So as I mentioned, it is a 0.03 degree when you're at 0 to 45, but then it gets a little less accurate up to 0.2 degrees at negative 50 to 150. So still, that's pretty highly accurate depending on your needs. If we continue to scroll down here, you'll see there's a link there to the primary learn guide. I've already got that open in a tab, so I'll bring that up. And here you'll see it's got pinout, some featured features from TI. So if you want to check this out, some nice details on the sensor itself. But for the board, we've got the board pinout here, and we have links to Arduino if you want to wire that up and put Arduino library and code on, or Python CircuitPython, or got a whole Whippersnapper set up there. You can just pick that from the add-ons within Whippersnapper. If you go to the downloads, you'll see we've got schematics here, the fab print, and some links to some CAD files, as well as, here's the data sheet from TI. Zoom in there a little bit, and you can see their description here is worth checking out, as well as all of the highly detailed info about use. So enough of that. Let's get to a demo. I'll show you what I got set up here. There is my sensor. So I've got that plugged in over a Stemma QT cable to a little Metro RP2350. You can see it down here below. The reason I have this held up above my desk here is so that I can hold some heated and cooled cups underneath it, just to show some change in ambient temperature there. So let me jump into temperature readings right now. So ambient temperature in the room for me is 30.38 degrees Celsius. So what I'll do now is let me take a hot beverage. So I've got a little thermal container here. Open that up carefully. I'm just going to slide that under there, and we'll see this is going to pretty quickly heat the air around, underneath and around the sensor. So that's going up a degree or two. This is, I think, maybe 150 degree Fahrenheit water, according to a electric kettle that I poured a little earlier. So that's warming that up, and then I'll pull that out of there, and I've got now you'll see that starts to drop immediately just because of ambient temperature, and I also brought a little blower here if I want to try to blow away some of that warmer air there and bring that closer to ambient. So that's back to about where we were. And then I've got a container here, a little cup that just has some ice cubes in it and a tiny little bit of water in the bottom. And that should pretty quickly start to cool us below ambient temperature, as that now cool air doesn't rise, but I think that that's close enough there that we'll start to get a little cooling effect here as it dips down 29.83 degrees. So that is in CircuitPython. Pretty easy to set up. You can see here we've got one library, Adafruit TMP117. You'll notice that's not the same name as this board, but the driver is the same for the TMP117 and the TMP119. Maybe we should have called it 11X, but I think we just had the 117 when this was written. But that library, import that, set up an I2C bus, and then create the object here. It's called, in this case, confusing here. Let me fix that. TMP117 is the library stuff, but I can call it anything I want, so I'll resave that. And here is the one call. So with that object set up in my main loop, all I'm doing is asking for tmp119.temperature. And that automatically returns the degrees Celsius. No conversion necessary unless you want to go into a different thing like Fahrenheit. And I'm asking for it with 2 decimal points of precision there. So easy enough to set up. And you can check out the Learn Guide for more info on that, as well as follow the links to the library for additional commands that you can run on it. A couple of other interesting things about this board. Here, I'll pull the ice cubes out from here. It has a hardware interrupt, so depending on your code and microcontroller environment, you can have the chip do an interrupt based on some condition. And you can also set alerts on a minimum and a maximum temperature. So that doesn't, excuse me, that doesn't have to be in your code. You can actually have right on hardware, right on the temperature sensor thresholds set so that you can guarantee that you're going to find out when the temperature has moved beyond your safe range. So with that, let me go and see if we've got any questions or comments in the chat. I'll bring up the Discord here. Cold Chain Asset Tracker this fall on CBS. Thanks, Todd. Let me check the YouTube over here. Where'd you go, YouTube? I've got a button for that, but I still have to find it. Let's see. Is this substantially different from the similar looking SHT45? Looks like it's a different chip. Yeah, so SHT, is that, yeah, SHT45, I think it's a different manufacturer than TI. And what it generally comes down to is the cost and the precision with this type of sensor. Roll VS says, why don't you have more outdoor sensors? Boring to measure temperature just inside. Yeah, that's a good question. I don't know. Maybe pose that question when we get Ask an Engineer back up and running. Ask Lamore if there are some outdoor sensors. I think we do have some outdoor sensors that come in like a weatherproof package. There are at least a couple of those. But I don't know, actually. I think typically these type of sensors, if we've made a breakout for it, it's because enough people have asked about a particular breakout. So maybe there's more people doing indoor sensing and making noise about it. But if you've got a chip that you like to use or want to try out and you don't see a breakout for it, then make some noise, let Lamore know, and if there's enough interest, she'll generally look into getting some samples and spinning up a board. So hope that helps. All right. Let's see. Did I say it could be used outside? No, I think this is meant for indoor. It's ambient air. I mean, it's not meant to be plunged into liquids. It's possible you could use it outdoor as long as you've got the right type of enclosure so that you're still getting ambient air but not exposing it directly. So I'd say you wouldn't want to just take this in a microcontroller and leave them outside as your outdoor temperature sensor. But I think with a little bit of enclosure design, sometimes these enclosures will be mostly weatherproof, and then they'll have some fan to bring in outside air, very small fan that'll spin every once in a while to stir the air up so it doesn't get stale in there. And in fact, I think there are some let me go to the Learn Guides. I think there is a project just like that. Let's go back on here. Let's do, in the Learn Guides, let's do outdoor. So here's one that Brent worked on, and let's see, this uses, so this is an air quality sensor and a temperature sensor. And yeah, this is a BME 280. It's also not ruggedized, so putting it into this enclosure with some holes drilled in the side, I think, was the solution on this one. And I think there's another example Ruiz Brothers did with a printed case that has some active air stirring going on. I'm not finding it right now, but yeah, so there's a couple projects on Learn that might help you out if that's what you want to do. And I think that is it. So once again, if you want to go and pick one up, that's the URL for you. That's the QR code. And I'm going to wrap this up. So let's bring these photos back up, and I can pull this thing apart right here. So that, oh wait, I've got QR codes. Let me get rid of those QR codes. Unplug this. There we go. So that right there is my product pick of the week this week. It is the TMP119 temperature sensor. It is a high precision temperature sensor. For Adafruit Industries, I'm John Park. This has been JP's product pick of the week, and I will see you soon. Thanks, everyone. Bye-bye.